Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the strangest, most quietly enchanting mysteries in all of physics. The idea that simply observing the universe might shape not only what happens now, but what has already happened, and perhaps even what will happen. And nestled inside that quiet strangeness is an even more daring question. Could the act of observing time itself help create the very conditions for time travel? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always a gentle joy to imagine all the places we gather from: midnight kitchens, dimly lit bedrooms, quiet balconies, and tiny pockets of stillness stretched across the globe. If you can, feel free to dim the lights, maybe turn on a soft fan or a warm lamp, and let yourself settle into a comfortable position. Tonight's subject is vast and strange, but we'll wander through it slowly, like walking through a silent museum after closing hours, where every echo feels thoughtful and every shadow holds a whisper of possibility. And if your mind drifts along the way, that's perfectly fine. Just let it float. We'll still be here, quietly unfolding the story. Now, as the room settles and your breath softens, let's begin our gentle journey into the question: what really happens when we observe the universe? And could observation itself be the spark that allows time to bend? There is a peculiar moment in physics, one so quiet and small that you could easily miss it, where the universe seems to hesitate before making up its mind. It happens when we look closely at very tiny things, the sorts of things too small to see with any ordinary light: electrons, photons, particles that drift more like soft possibilities than solid objects. And when we look at them, really look, something changes. The universe seems to fold inward, choosing one version of itself over many. It is as though reality, in its delicate way, is shy. Physicists call this the observer effect, but the phrase sounds sharper than the phenomenon feels. In truth, it behaves more like touching a bubble with the tip of a feather. The bubble responds, not because you meant to influence it, but because contact itself is enough. In the quantum world, observing is never a passive act. To see an electron, you must shine light on it, and shining light means sending tiny packets of energy that bump into the electron and alter its course. Even the gentlest glance is still a kind of cosmic nudge. One of the clearest stories we have of this strange behaviour comes from the double-slit experiment, which you may have heard described before. Imagine, just for a moment, a quiet hallway with two narrow doorways. A marble tossed toward them must choose one doorway or the other. But a tiny particle, like a photon, sometimes behaves less like a marble and more like a soft ripple. Instead of choosing one doorway, the ripple passes through both. The result is a pattern that appears on the far wall, gentle alternating stripes, made by two waves blending, overlapping and interfering with one another. But here comes the cosmic glitch. If you place a tiny detector by the doorways to watch which one the particle chooses, that delicate ripple vanishes. The wave collapses into something more definite, more particle-like. The stripes disappear, replaced by the simple pattern of individual impacts. It is as though the universe quietly switches modes the moment it feels your eyes upon it. This can feel unsettling, like the floor shifting beneath your feet. Yet the truth is calmer than it appears. The world is not trying to play tricks on us. It is simply showing us that at the smallest scales, things do not exist in fixed states until they must. Possibilities linger like mist, and observation acts like a breeze that gently brushes the mist into a single, clear shape. But there's another layer here, one that turns this simple experiment into something far stranger. If observing tiny particles can change what they do, what happens if we try to observe something much larger and much grander? Something like time itself. Could time also hesitate in the same way, hanging between possibilities until observed? Or are these two domains, particles and space-time, completely separate, destined never to touch? A comforting thought to hold here is that the science doesn't demand complex formulas or harsh symbols. Even equations, if you peel away their sharp edges, are simply stories written in numbers. And so instead of speaking of wave functions or amplitudes, we can say something gentler, that a quantum object carries many potential stories at once, and the act of observing is the moment we discover which story the universe chooses to tell. Now imagine this. What if time, too, holds multiple stories, possible futures, possible pasts, waiting quietly in the wings? What if observing time, measuring it, thinking about it, or even longing to move through it, nudges the universe the same way a beam of light nudges an electron? This doesn't mean that consciousness reshapes the cosmos with a thought, but perhaps observation is more like listening closely to a faint clock in the dark. The clock does not change because you listen. Instead, listening reveals what was faint, and the very act of hearing makes the rhythm feel more real. As we move through this exploration tonight, we won't rush. We'll simply follow the soft pull of curiosity, letting each idea settle before lifting the next. For now, it is enough to recognize that the observer effect is not only a scientific curiosity, but also a doorway, a hint that reality may be more fluid, more responsive, and more poetic than it first appears. And perhaps, just perhaps, within that fluidity lies a new way to think about time, not as a rigid arrow shooting forward, but as a quiet sea shaped by the way we watch its tides. There is a quiet idea at the heart of quantum physics, one so soft and subtle that it often slips past unnoticed. It is the realization that the universe, at its smallest scales, does not present itself fully formed. Instead, it hovers in a kind of delicate openness, like a story waiting to be told. When we observe it, that story settles into a single version. But before the moment of looking, many threads are possible, all resting together in a gentle cloud of maybes. To understand this without harsh symbols or dense equations, imagine standing in a dim room at dawn. The shape of the furniture is there, but not fully clear. The chair might be facing slightly left or slightly right. You cannot say until light reveals it. Observation doesn't change the chair in any dramatic sense. It simply brings into focus what was once a blur. In the quantum world, this effect is more dramatic, because the blur is not a lack of clarity in our eyes, but a true state of multiple possibilities coexisting until the universe chooses one. Physicists sometimes describe this behavior using the language of waves. A particle is not a tiny marble, not at first. It acts more like a soft ripple spread across a pond, occupying many places at once. This ripple is not made of water, but of possibility. The term once used in equations, often shown as a curvy symbol called psi, can be spoken aloud as the gentle wave of potential outcomes. And when we measure a particle, we are not calculating some rigid number. We are touching that ripple and asking it to choose a single crest. But the story becomes even more interesting when we add something called decoherence, a word that can sound intimidating until we soften it a little. Decoherence is what happens when a quantum system is no longer perfectly isolated. It's like trying to hear a single violin playing in an open field, only to have the wind and distant birds blend with the sound. The purity of the note dissolves, the many overlapping possibilities, so clear and delicate when untouched, become drowned out by interactions with the rest of the universe. This is why electrons, photons and atoms behave so strangely when we manage to keep them alone, but behave so ordinarily when they are surrounded by air, light and warmth. It is only in the quiet, shielded spaces of the laboratory that quantum behavior reveals itself. Everywhere else, the environment acts like a constant chorus of tiny nudges, pushing particles into single, definite states long before we ever get the chance to look. If we think of reality as an orchestra, then decoherence is what happens when every instrument in the hall begins playing at once. The delicate solo, which is the quantum world, is quickly overwhelmed, replaced by the familiar harmony of the classical world we experience every day. This blending happens incredibly fast, so fast that we usually never notice the subtle moment where possibility becomes certainty. Yet even knowing this, the observer effect still raises an intriguing question. If looking at small things changes how they behave, what does it mean to observe something as grand as time? Time feels solid, dependable, like the steady ticking of a metronome. But is that because time itself is fixed, or because the way we experience it is shaped by our role as observers? Our hearts beat. Our memories form in linear threads. Our minds arrange the world in sequences. In this sense, we do not merely exist in time, we participate in weaving it. Scientists have long explored whether time is something fundamental or something that emerges from deeper laws. Some modern approaches whisper a surprising idea that time might not exist at the deepest level of reality. Instead, it might arise from relationships between things, the same way rhythm arises only when two musicians listen to one another. If this is true, then the act of observing time, of noticing its passage, might play a role in shaping how we experience it. Imagine two people walking through a dark hallway with no clocks, no windows, no cues from outside. Time becomes hard to measure. It stretches and compresses unpredictably. But as soon as they carry lanterns, as soon as they can see one another's footsteps, the rhythm of movement returns. They begin to feel time again, not because time changed, but because they did. Their awareness restored the sense of flow. In a similar way, our observation of the world may be part of what molds time into the smooth river we perceive. Perhaps time is not an independently flowing stream, but a pattern woven together by interactions. Interactions between particles, between systems, between us and the universe. The double-slit experiment hints at this in an indirect way. When we watch which path a particle takes, it behaves like a point. When we do not watch, it behaves like a wave. It is as though the particle waits for us to define the stage on which it performs. This doesn't mean consciousness alters the universe by force. Rather, it suggests that the universe holds more than one way of expressing itself, and observation is what gently selects the form it takes. The softness of this idea is important. We're not suggesting that thoughts alone reshape reality, or that imagination bends space-time like clay. What we are exploring is the possibility that reality has a flexible side, a responsiveness that becomes especially noticeable at the quantum level. And once we see that flexibility in nature's smallest patterns, we might begin to wonder how far that flexibility extends. Could time, like the quantum world, hold many potential shapes? Could its flow shift subtly, depending on how it is observed, measured, or interacted with? These are not questions with quick answers. They're invitations to step deeper into the mystery, much like walking into a forest where the trees grow more unusual the farther you travel. And yet there is a certain comfort in knowing that the universe is not rigid. It is not a fixed mechanical machine grinding unchanging gears in the dark. Instead, it seems to carry a softness at its core, a willingness to adapt, to hold multiple possibilities, and to reveal different faces depending on how gently or closely we look. As we continue, we'll follow this softness into the heart of time itself, exploring what happens when the future and the past seem to blur, when choices ripple backward, and when the universe feels less like a clock and more like a story unfolding all around us. And for now, it's enough simply to recognise that reality has a shimmering quality, one that appears most clearly when we meet it with quiet attention. There is a quiet idea in modern physics that feels almost like a secret, whispered at the edge of our understanding. It says that time, the steady companion we take for granted, the flow that carries us from morning to evening, might not be something the universe possesses on its own. Instead, time might be something that appears only when parts of the universe look at one another. It is a gentle, almost poetic proposition that time is not the stage of reality, but a pattern that emerges when there is someone or something there to measure it. For most of our lives, time feels solid. We grow older, clocks tick, seasons turn, and memories stack themselves neatly behind us like pages in a book. But when physicists examine the deepest layers of reality, they find that time does not sit there waiting. The fundamental laws, the ones describing particles and fields, and the quiet undercurrents of the cosmos, do not insist that moments must line up in order. They do not include a built-in arrow that points from the past to the future. The equations, if we soften them into simple ideas, speak of relationships, states, and changes, but not of a universal clock. This is where the page-routers mechanism enters the conversation, though we need not use its name more than once. The underlying idea is gentle enough. Imagine that the universe, taken as a whole, is timeless, not frozen, not static, just complete, like a vast painting that already contains every colour, every detail, every nuance. In such a universe, time does not flow, it simply is. But inside this grand picture, smaller pieces interact with one another. One part of the universe may act as a clock, changing in a predictable rhythm. Another part may be the system, whose evolution we wish to observe. When the clock and the system become connected, entangled in the soft sense of being linked like two dancers who move in response to one another, a sense of time emerges for any observer who uses the clock to interpret the state of the system. In other words, time unfolds only when something inside the universe uses something else inside the universe as a reference. It is not an external river flowing past us. It is a melody created when instruments are compared. A simple way to picture this is to imagine two friends sitting by a campfire. One taps their foot steadily. The other listens to the rhythm and matches their breath to it. Their shared sense of time comes not from the forest around them, nor from the stars overhead, but from the relationship between heartbeat, breath, and soft footfall. Without one another, the rhythm would feel different, or perhaps not be noticed at all. But together they create a shared cadence, the feeling of time. Now extend that idea to the universe. If two quantum systems are linked, one might become the reference the other uses to define its own changes. From outside, the entire setup may seem silent and still, but from inside there is motion, sequence, and flow. Time appears, not like a command from the cosmos, but like a pattern rising from within. This perspective naturally brings us back to observation. If time arises from relationships and measurements, then observing is not just a passive act. It is part of how the universe reveals structure. When you watch a clock tick, you're not merely witnessing time, you're participating in the process that gives time meaning. Without a clock, or without the attention you give it, the idea of a second becomes soft and uncertain. With observation, it sharpens and becomes real. This is not to say that time is an illusion. That word is too harsh, and not at all what physicists intend. Time is as real as temperature, not a fundamental object, but a property that arises when many pieces come together. Temperature appears when molecules move and collide. Time appears when systems change in relation to one another. Both require context. Both require interaction. And so we begin to see the observer effect in a new light. It is not merely that observing a particle disturbs it. Observing is also a way of linking yourself to the system, becoming part of the pattern through which physical reality expresses itself. At the quantum level, observing something helps determine its state. At the level of time, observing helps determine the order in which events appear. Imagine a spinning coin on a table. If you close your eyes, the coin is neither heads nor tails. It is in motion, a blur, a dance. When you open your eyes, the coin settles into one outcome. You don't force it. You simply witness what it becomes. Now imagine that instead of a coin, you are looking at a moment. You measure it with your pulse, your breath, the subtle ticking of your inner sense of duration. In doing so, you help give that moment shape. This idea becomes even more intriguing when we consider how memories work. A memory is not a recording, but a reconstruction. Each time you recall something, you observe it again, and in observing, you reshape it slightly. Your past is therefore not a fixed object sitting behind you. It is something that becomes clearer through the act of remembering, and softer through forgetting. It is a kind of observer effect woven into your own experience. If this is true for memory, might it also be true for time itself? Could our perception of time, our awareness of sequence, be part of what brings time into being in the first place? Could the flow we feel be a quiet collaboration between the universe and the act of observing it? We're not claiming that consciousness bends time like clay. Rather, we're exploring a subtle partnership, a universe that holds many possible sequences and a mind that helps select one. Observation in this sense is not a force but a conversation. And this raises a question that will guide us gently forward. If observing time helps shape it, what happens when we attempt to observe the borders of time more closely? The edges between past and present, between what has happened and what might happen. Does time become firmer under our gaze, or does it reveal something unexpected? Something that suggests its shape is not fixed, but flexible. We will drift toward that question soon, letting each idea settle like dust in warm light. For now, it is enough to sit with the possibility that time is not something we merely pass through. It is something we help unfold moment by moment, simply by observing the world around us and noticing how it changes. If you sit quietly for a moment and close your eyes, you can feel time without looking at any clock. You sense the slow rhythm of your breath, the soft beat of your heart, the gentle settling of thoughts as they drift from one shape into another. Even without markings on a watch face or the subtle hum of a digital timer, something inside you keeps track of moments passing. It is not perfect, and it is not mechanical, but it is steady enough that you always know whether a second has slipped by or a minute has stretched open. This inner sense of time is not separate from the world. It is part of the way you observe it. Every heartbeat is a quiet reminder that time is something you carry within you as much as something you measure outside. In this way, each person becomes a kind of clock, not one that ticks with gears or crystals, but one that measures change through experience. When scientists think about time, they often talk about reference frames, different perspectives that define how events unfold. But to translate that idea softly, imagine that your mind is like a lantern in a dark room. Wherever you shine it, the objects nearby take on shape and distance and position. Without the lantern's light, the room still exists, but its layout becomes uncertain. You are the one who reveals structure simply by looking. In the same way, your inner sense of passing moments creates a framework in which life gains order. This is not just poetic imagery. Human beings are deeply tied to rhythms. Our sleep follows the cycle of sunlight. Our bodies adjust to subtle cues of temperature, food, and sound. Even memory arranges experience into sequences that feel like stepping stones across a river, each moment leading to the next. So although time can be described with mathematical precision in physics, the experience of time, the one we live, is softer, more fluid, and shaped by the way we observe the world. There is an old idea in philosophy that says we're not simply moving through time. We are co-creating its flow by noticing how things change. When you watch a candle burn, you are both witnessing time and helping define it. A candle without an observer still melts, of course, but without anyone to compare its shape now to its shape later, the idea of before and after loses some of its meaning. Clocks help us make these comparisons more precise, but the ability to sense change comes from within. We are built to notice. In quantum physics, this idea becomes even more intriguing. When a system is measured, the measurement links the state of the system with the observer or the measuring device, forming a relationship. And relationships are where time emerges. Instead of thinking of time as a universal river flowing past all things equally, we can imagine it as a pattern that forms whenever two parts of reality interact. It is not that time is invented by observation, but that observation provides the structure, like handrails on a staircase, that lets us feel the direction and pace of the journey. Consider a simple example. If you watch a leaf fall from a tree, you see a sequence. First, it clings to the branch, then it loosens, then it drifts downward in little spirals. Your mind records this in order, and in doing so, you create the sense of time flowing. But if you were to see only the leaf on the ground with no memory of how it arrived, that stretch of time between branch and earth would not exist for you. You would know the leaf must have fallen, but not when. Without observation, the world still changes, but the story is missing a narrator. There's a similar idea in psychology. Our minds stitch experiences together in ways that create the illusion of continuous time. Tiny gaps in perception are quietly smoothed over, so we can feel the world as one unbroken flow. In this way, the observer inside us acts like a gentle editor, creating the narrative of a moment. This perspective does not contradict physics. Instead, it complements it, suggesting that time is both internal and external, a dance between the universe and the observer. It also hints at why time feels so different depending on our state of mind. When we are anxious or rushed, time sharpens into short, rigid intervals. When we are relaxed or content, minutes unfurl like soft ribbon. The same number of seconds may pass, but the experience of them changes because the internal clock, the observer, is different. Now imagine applying this idea not just to everyday perception, but to the universe itself. If time arises from interactions and observations, what does it mean to observe time more closely? What happens if you try to measure it with greater precision, or question its structure, or even attempt to move through it deliberately? When scientists measure time on extremely small scales using atomic clocks, they find that time is not the same everywhere. A clock placed slightly higher above the ground, just a few centimeters, ticks ever so slightly faster than one below it. Gravity stretches time, motion distorts it, but these distortions only reveal themselves when someone compares one clock to another. Without that act of comparison, the difference might as well not exist. The observer becomes part of the measurement, and in a gentle way, part of time's shape. This becomes even more fascinating when we consider what happens if the observer could influence not only how time is measured, but how time flows. We're not speaking about controlling time in a literal science fiction sense. Rather, we're imagining a universe where the very structure of time depends on relationships, between clocks and observers, between memory and expectation, between measurement and reality. If relationships create the sense of time, then observing time becomes more than a passive act. It becomes part of the machinery of time itself. The thought is subtle and does not claim that consciousness bends the cosmos. Instead, it suggests something gentler, that the experience of time is intertwined with observation, and that the universe might carry multiple potential rhythms until the observer chooses one to follow. Just as listening to a piece of music helps define its tempo, observing the world helps define the flow of time you inhabit. This leads us toward a deeper mystery. If time is partly shaped by observation, what happens when observation reaches into the edges of time, into the boundaries where past, present, and future become difficult to separate? As we drift toward that question, it becomes clear that the observer is not merely watching the universe unfold. The observer is one of the threads woven into the tapestry of time itself. There is a moment in physics that feels almost like a tale from a dream, a kind of dream where events slip out of order and yet somehow still make sense. In this moment, it appears as though the universe hesitates not only before a choice, but even after it. A decision made in the present seems to ripple backward, influencing what must have happened earlier. It is not true backward in time causation, not in the literal cinematic sense, but the appearance of it is enough to make even seasoned scientists pause. And for those listening in the quiet of night, it invites a question as soft as it is profound. Does time truly know which way to flow? This story begins with a man named John Wheeler, who wondered what would happen if we delayed our choice in the famous double-slit experiment. Instead of deciding early on whether we want to see a photon act like a wave or a particle, what if we waited until the very last instant? Until the photon had already passed through the slits, already travelled the path, already made its silent journey across the dark space between source and detector. If we chose to observe its path only after it had taken the journey, would it matter? The surprising answer is yes, and no, and maybe. And all three of those feelings sit gently together, the way colours blend in a sunset. To tell this softly, imagine a traveller walking through a narrow mountain pass. There are two trails they might take, one to the left, one to the right. If you shine a lantern from the start, watching the traveller closely, they choose one path, and you see which one they take. But if you wait in the darkness, letting the traveller walk without light, something unusual happens. Instead of choosing just one trail, the traveller behaves like a drifting sound, echoing through both paths at once. Only when you shine your lantern at the end of the pass, long after the traveller has already passed the point of choosing, does the world settle into a single trail. In Wheeler's experiment, our lantern is a detector, our traveller is a photon, and the universe behaves like the quiet echo in the mountain. If we decide to look for which path the photon took, the interference pattern disappears, just as if we had been watching from the beginning. If we decide not to look, the wave-like pattern remains, even though the photon passed the slits long before we made that choice. The photon does not change its past, but the story we tell about its past depends on the choice we make now. The universe doesn't rewrite history, it simply waits to decide which version of history becomes meaningful. Some describe this as the future deciding the past, but that is not quite right. A gentler way to put it is that nature holds several possible histories in suspension until the act of observing, whenever it occurs, selects the one that aligns with the present moment. It is like finding a diary whose earlier pages are blank, only to see words appear as you read further in the book. The ink does not flow backward in time. Instead, the story reveals itself in the order that makes the most sense as you experience it. Things grow even stranger when we bring in the quantum eraser, a variation on Wheeler's idea. In this experiment, the universe allows us to erase information about which path the photon took, even after it has been detected. And when that information is gently erased, the interference pattern returns. It is as though the universe shrugs and says, "If you cannot know the path, then I will not choose one." The photon's behaviour, already recorded on the screen, arranges itself into a pattern consistent with the idea that it behaved like a wave. This does not mean the universe rewinds or changes its mind. It simply means that the way we understand events and the patterns we see in them depends on the information that exists in the present. When information is restored or removed, the patterns shift accordingly. Reality is not rewritten, it is reinterpreted. To soften this further, imagine a musician playing two soft notes, one high and one low. If you know which note was played first, the melody has a certain structure. But if you forget, if the memory of the order is erased, your mind blends the notes together, hearing them as a single harmony rather than a sequence. The sound itself does not change, only your relationship to the sound changes. In the same way, the quantum eraser does not alter what happened, but alters what the universe allows us to say happened. This opens a curious doorway into thinking about time. If the patterns we observe depend on what we know now, then perhaps time is less about events stacked neatly in order and more about the connections between them. The universe may not care about the arrow from past to future in the way we do. It may be more like a tapestry where threads cross and overlap, and where meaning arises not from the sequence of stitches but from the pattern they create together. And yet we should move gently here. It is tempting to leap to ideas of retrocausality, of futures altering pasts, of messages slipping backward along the timeline. But the experiments do not require such leaps. Instead, they suggest that the universe does not commit to one story until it must. Before that moment, several versions linger in quiet coexistence. This does not make time unreal. It makes time supple. It makes the past feel less like a fixed road and more like a path shaped by the relationships we discover along the way. When we look at the universe with a new type of measurement or a new insight, we draw different boundaries around what counts as the past. We see structure where none existed. We erase distinctions that once felt absolute, and in doing so, we reshape the story without ever changing the events themselves. It is a reminder that reality is not built from isolated pieces but from connections, between places, between moments, between knowledge and experience. The observer is not outside the universe looking in. The observer is part of the same fabric, woven into the same patterns, and so the question becomes softer, more introspective. If the universe waits to decide which version of the past to reveal, what else might it be waiting for? What other choices made now or later might help shape the way time appears to flow? How much of the world is determined by what is, and how much by what becomes visible when we turn our attention toward it? These questions carry us quietly toward the heart of the mystery. For if observing the universe affects how patterns unfold, perhaps observing time affects how time unfolds. And if the past can feel fluid depending on what we learn now, then the boundary between past and future may not be a barrier at all, but a soft horizon we have only begun to explore. There is a feeling that comes over you when you think about time travel, a mixture of wonder and unease, as if you are standing at the edge of a high cliff, looking down at a landscape that is both familiar and impossible. You sense the beauty of the view, but also the strangeness of the drop. This feeling grows stronger when you imagine stepping backward into your own past, into a moment that has already shaped you, already lived, already closed its doors behind you. What would it mean to touch a moment that is supposed to be finished? This question leads us into one of the most famous puzzles in the study of time, the paradox that arises when the possibility of altering the past is taken seriously. Perhaps you have heard the classic version. A traveller steps back in time and prevents their own ancestor from living long enough to continue the family line. If the ancestor does not survive, the traveller is never born. And if the traveller is never born, they cannot go back to interfere. The loop collapses, the story breaks. The universe seems to be caught in a contradiction. The grandfather paradox, as it is often called, is a puzzle not because it is mathematically complicated, but because it presses on a deeper truth. The past feels immovable. It is the part of time we cannot revisit, cannot touch, cannot revise. It is the solid ground beneath our feet. And yet the idea of time travel invites us to consider what happens if that ground becomes soft. To understand why the paradox matters, imagine a painting that is completed but somehow allows new brushstrokes to slip into it long after the artist has finished. The new strokes blend into the old ones, but if those strokes alter the shape of the painting enough, They might remove the very signature that permitted the painting to exist. The artwork becomes self-erasing, a contradiction in colour and form. In physics, contradictions of this sort are deeply unsettling. The universe, as far as we can tell, has little patience for them. Events unfold in ways that preserve consistency, even in the most bizarre quantum experiments, where possibilities flutter in and out of focus, like moths around a lantern. The final outcomes are always coherent. They make sense, even if they surprise us. So what happens when we invite time travel into this picture? Does the universe risk contradiction? Or does it find a way to avoid it, weaving events together so no paradox is allowed to survive? One gentle way to think about this is to imagine the past not as a rigid line, but as a woven fabric. Each thread is a moment, each stitch a connection between events. You move along the fabric, from one point to the next, and behind you the weave settles into place. Now imagine trying to lift a thread that has already been woven. If you tug too hard, the fabric resists. It shifts only in ways that preserve the pattern. You cannot erase a stitch without creating a tear, and the universe seems to dislike tears. Instead, the fabric adjusts around your tug, rearranging itself just enough to hold everything together. This is where the paradox softens. If time travel were real, the universe might not allow contradictions to appear at all. Rather than permitting you to erase your own existence, it might guide events in a way that quietly prevents such contradictions. Perhaps your attempt to alter the past always fails, not because the universe forbids you openly, but because the weave adjusts so subtly that your actions never reach the point of breaking the pattern. In everyday life, we often encounter softer versions of this idea. Think of times when you tried to correct something that already happened, a misunderstanding, a hurried remark, a misstep. You may influence how others remember it, or soften its effects, but you cannot truly erase the original moment. The past stays where it is, and your new actions wrap around it, shaping how the story is told, but not the bones of the story itself. Another way to imagine the paradox is with a river. You step into the water and try to push a stone upstream. The stone moves a little, but the flow of the river shapes your effort. It redirects your hands, nudges the stone in its own direction, and ensures the river keeps running smoothly. You are free to act, but not free to shatter the river's course. This mirrors a deeper principle that physicists have proposed, that the universe may only allow time travel in ways that preserve consistency, not because of rules written in an ancient cosmic script, but because inconsistency itself may simply not be possible. The universe unfolds in patterns that fit together. Every event, every cause and effect, every moment is part of a larger whole. The paradox appears only when we imagine the universe as a loose collection of separate events we can rearrange at will. But if the universe is a tightly woven tapestry, each thread connected to many others, then the past cannot be replaced. It can only be approached from new angles. This does not eliminate the strangeness of the paradox. It simply reframes it. Instead of asking, what if I travelled back and erased myself? We might ask, what story would the universe allow me to become part of without tearing the fabric? In this light, time travel becomes less about rewriting the past and more about moving within a structure that always keeps itself whole. Viewed this way, the paradox becomes a doorway into something more subtle, a hint that the past may be more connected to the present than we realise, and that any attempt to interact with it, whether through memory, imagination, or something more literal, will always align with the deeper logic that keeps the universe consistent. And as we drift forward, the gentle question lingers. If paradoxes cannot survive, then perhaps time itself is arranged in ways that naturally avoid contradiction. Perhaps the universe has already found the path that allows time to loop without breaking, and in that possibility lies a quiet, intriguing mystery waiting just ahead. There is a quiet wisdom woven into the universe, a kind of soft insistence that things fit together, that events line up in ways that do not shatter their own foundations. Even when nature behaves in the strangest ways, when particles flicker between possibilities, or when time seems flexible rather than rigid, there is still a sense that the story once told must make sense. The universe, as far as we can tell, does not allow impossible chapters. It does not tolerate sentences that contradict themselves. Instead, it guides events gently toward coherence. This idea becomes especially important when we step deeper into the conversation about time travel. After we acknowledge the paradoxes that appear the moment we imagine stepping into our own past, the next question arises naturally. What would the universe do to avoid those contradictions? Would it prevent time travel entirely? Or would it allow it in some form, but only under certain conditions that preserve the consistency of the story? One proposal, introduced softly by physicists exploring the logic of time, is something called the principle of self-consistency. We will not use the hard mathematical phrasing here. Instead, imagine it this way. If time were to bend into a loop, then everything within that loop must fit together without conflict. Events must support one another, not tear each other apart. A person travelling into the past cannot create a situation that makes their own journey impossible. They cannot erase the very branch they stand on. In the language of gentle metaphors, this principle says that the universe is like a circle of trickling water. Every drop moves along its path, not breaking the ring, but sustaining it. If one drop tried to flow against the current, the circle would reshape itself just enough to keep the ring unbroken. This doesn't mean the universe forces events. It simply means that within a closed loop, only the kinds of events that preserve the loop can occur. A simple way to sense this idea is to imagine a path in a forest that leads you back to where you started. As you walk, you encounter stones, branches, and curves that feel familiar. If you try to step off the path, the undergrowth is thick, gently discouraging you. You are free to wander, but the forest guides you toward the loop. You remain part of the pattern, and the pattern remains whole. This principle paints time travel not as a chaotic rewriting of history, but as a subtle weaving of events that fold seamlessly into one another. A traveller might influence the past, but only in ways that are compatible with the world that traveller came from. A gentle nudge, a small event, a quiet interaction. All of these might be allowed. But anything that would unravel the traveller's own existence would simply never happen. The universe would nudge them away from it, perhaps without them ever realizing. You can think of it as the difference between pushing a door that is unlocked and pushing one that is firmly closed. When the door is locked, you may push without knowing why it will not move. You feel resistance, but not explanation. In the same way, the universe might allow many actions in the past, but block those that would create impossible consequences. To the traveller, it might feel like coincidence, luck, or subtle misdirection. But to the universe, it is simply maintaining the integrity of its story. This gently resolves the paradox without making time feel brittle or fragile. It suggests that time is strong, not rigid, but resilient. Like a tree that bends in the wind without breaking, time flexes just enough to allow loops, while never snapping under contradiction. Another way to approach this idea is to picture a mural painted on a great wall. The mural is vast and intricate, telling a story across its surface. If an artist steps back into an earlier section of the mural to make changes, they must do so in a way that does not destroy the parts already painted. They may add details, brighten colours, correct lines, but they cannot create a scene that contradicts what lies further along the wall. If they tried, the mural would lose its coherence. Instead, the artist works with what is already there, shaping and reshaping in harmony with the whole. In physics, this gentle harmony is not merely philosophy. It emerges from the structure of the equations themselves. While the mathematics is too sharp to bring directly into a calm nighttime reflection, its meaning can be softened into an image. The universe behaves like a storyteller who refuses to allow plot holes. The tale can twist and turn, but the story must support itself. This idea also influences how we think about loops in time. A time loop need not be a chaotic or impossible shape. It can be elegant, like a spiral staircase that returns you to the same floor, yet allows you to see it from a new angle. The steps do not contradict one another. They simply follow a path that is both circular and ascending. A person walking on such a staircase is never confused by the loop. They experience it as a continuous, coherent journey. If time loops exist, they might resemble these staircases. The traveller returns to a moment that already contains the seeds of their arrival. Their presence is not a disruption, but a fulfillment. They may even be the reason certain events happened in the first place, not because they forced them, but because the loop required them. This brings a kind of peace to the concept of time travel. Instead of imagining a universe full of paradoxes and impossible contradictions, we imagine one where every event has its place, woven seamlessly into a larger pattern. The past is not fragile glass that shatters when touched. It is more like a river whose currents always find a way to carry water forward, even when the water is looping back from a far-off future. The principle of self-consistency does not prove that time travel is real. It simply shows that if time travel were possible, the universe might already have the tools to handle it elegantly. It would not allow paradoxes. It would not allow impossibilities. It would allow only the kinds of loops that tell a complete, harmonious story. And as we drift toward deeper questions, this idea prepares us for the next gentle step. If the universe avoids contradictions so gracefully, what kinds of loops might it allow? What stories might it permit to fold into themselves without breaking? And how might those loops feel from the inside to someone who becomes part of them? These are questions the universe answers softly, and which we will follow in the next stretch of our quiet journey. There is a moment in the study of time where imagination and physics seem to meet halfway, as if the universe is leaning forward to whisper a possibility that is astonishing, strange, and yet described calmly by the very mathematics that govern space-time. This possibility is something called a closed time-like curve, though we can set aside the complicated name and focus instead on the gentle idea beneath it. A path through the universe that bends so gracefully that it loops back to its own beginning. To picture this without symbols or equations, imagine strolling through a quiet forest in the late afternoon. You walk along a soft dirt path that curves between the trees, bends around a moss-covered rock, and circles a small clearing. After some time, you realise the path has carried you back to the very place you started. You did not retrace your steps. You simply followed the curve and it brought you home. This is what a closed time-like curve represents, not in space, but in time. A route you could travel that returns you to an earlier moment in your own history without ever turning around. The idea emerges naturally from Einstein's picture of space-time, which treats the universe as something that can be bent or curved by mass and motion. In the softened language suitable for a calm night, we can say that space-time is like a vast elastic fabric, responsive to every star, every planet, and every movement. Under certain extraordinary conditions, ones that are far beyond anything we can achieve with current technology, this fabric could twist so steeply that time itself folds into a loop, allowing a traveller to return to a moment that, from another perspective, is long gone. This may sound like a contradiction, but the beauty lies in the fact that the universe does not treat time as rigid or absolute. Time can stretch and slow near massive objects. It can twist near rotating bodies. It changes rhythm when things move quickly. All these behaviours have been observed in ways that require no exotic speculation. Satellites feel time differently from clocks on Earth, and our devices must account for this to guide airplanes and ships accurately. If time can stretch and bend, then in the right conditions, it is not unreasonable to imagine it bending enough to form a loop. But while the mathematics behind this idea can grow sharp and intricate, the core concept can be softened into something familiar. Think of time as a ribbon held loosely in your hands. If you pull gently, the ribbon tightens. If you twist it, a loop may begin to form, and if you guide that loop carefully, it touches itself, creating a circle within the long strip. A closed, time-like curve is like that inner circle, a contained path within the larger flow of time. When physicists explore these loops, they often imagine objects, or sometimes people, moving along them. But rather than focusing on travellers, it's more peaceful to focus on the curve itself. A closed loop in time suggests that the universe might allow events to be linked in ways that do not depend on the usual forward flow. Instead, the story becomes circular. An outcome might lead to a cause, and a cause might lead to an outcome, until both settle into a self-sustaining cycle that needs no outside origin. This circularity does not break logic. In fact, it preserves it. Every event on the loop follows from the one before it and leads to the one after it, just as in any other part of time. The only difference is that the end of the story flows seamlessly back into the beginning. It's like listening to a quiet piece of music played on repeat. If the melody loops smoothly, you may not even notice where the starting note becomes the ending note. The music simply continues. One of the gentler consequences of such loops is that some events may not have a clear beginning. Imagine a book lying on a table, its pages filled with wisdom. A traveller finds the book, studies it, and carries its knowledge into the past. There, they use that knowledge to write the same book, word for word. Who was the original author? In this loop, the question evaporates. The book exists because the loop supports it. Knowledge flows through the circle without needing a first source. The story maintains itself. This does not mean that the universe is playful or mischievous. It simply means that time may allow patterns that are self-contained, just as nature allows shapes that are symmetric or balanced. A loop is not necessarily impossible. It is simply unusual, like a rare shell on a quiet beach. To sense this more deeply, imagine a river that circles a small island before continuing downstream. A leaf could drift endlessly around the island, carried by the current in a perpetual loop. To an observer standing on the shore, the leaf seems to return again and again, always authentic, always in motion, yet never leaving the cycle. The leaf is not stuck. It is simply part of a local rhythm within a larger flow. A closed time-like curve is like this local rhythm. It does not require the entire river of time to loop. Only a small region needs to fold into itself, creating a contained pathway through which something could cycle. Outside the loop, time flows as usual. Inside the loop, events feed into themselves. Of course, these loops, if they exist at all, appear only under extreme and exotic circumstances, conditions involving immense gravitational influence or unusual configurations of space-time. They are not the kind of thing that could appear in an ordinary room or in the everyday world of clocks and calendars, but the fact that our best theories of gravity allow them at all is still remarkable. It opens a doorway to thinking of time not as a single straight line, but as a landscape with valleys, twists, and occasional closed trails. Some people fear that loops in time would cause chaos, but the self-consistency we explored earlier suggests that any loop the universe permits would naturally avoid contradictions. The loop would be its own justification, its own origin, its own consequence. It would be harmonious rather than disruptive, and so closed time-like curves become more than a mathematical curiosity. They become a hint that the universe may have a soft flexibility to it, one that allows time to fold without tearing, to loop without breaking, and to connect events in ways that do not rely on a simple forward march. As we drift toward deeper layers of the mystery, the idea settles gently within us. If time can loop under the right conditions, what stories might those loops contain? And what might it feel like for someone to find themselves inside a circle of moments that supports itself? a path that always leads back to its beginning. There is a certain kind of story that feels as though it has slipped out of the grip of ordinary causality, a story that seems to hold its own weight without ever leaning on a clear beginning. It is the kind of tale where the origin dissolves softly, like mist fading into the morning air. No matter how carefully you search for the first spark, the starting point keeps moving, always just behind the horizon of explanation. In physics, this quiet phenomenon carries a name, the bootstrap paradox. But rather than approaching it as a complicated scientific phrase, we can think of it simply as a loop where cause and effect support one another so perfectly that neither one comes first. To picture this in a gentle way, imagine finding a handwritten note in your pocket. The note contains a piece of wisdom, perhaps a small poem, or a reminder that you needed at exactly the right moment. You don't remember writing it. Later, you travel back in time and meet your younger self, who seems lost or uncertain. Feeling the need to help, you hand them the note. They tuck it into their pocket. Years pass, and one day the future version of you finds that same note again. The loop closes. The message has no author, no origin, and yet it exists. Past forward, past backward, endlessly supported by its own cycle. The paradox is gentle, not sharp. It does not scream contradiction. It hums with a strange kind of consistency. The note exists because it will exist. The loop holds it. You do not need a cause outside the circle, any more than a melody on repeat needs a first bar once it is already playing. The tune sustains itself simply by looping. Physics allows us to imagine such loops because time, in the deeper layers of theory, is not always a straight line. It can curve, fold, and connect back onto itself under extreme conditions. In such places, a future event might be tied into a past event so closely that the distinction between cause and effect loses its clarity. Instead of a chain, we get a circle. To soften this further, think of a candle flame lighting another candle. If you place the candles in a ring, each one lighting the next, you can trace the flow of fire in one continuous circle. The flame has no single beginning. It is sustained by the loop. Remove any candle and the circle breaks. Keep them all and the flame can travel around forever. A bootstrap paradox is like this ring of candles, an event sustained by the loop that contains it. The beauty of this idea becomes clearer when we apply it to time travel. Suppose someone in the future invents the technology to travel backward in time. They step into a machine and emerge in the past, carrying with them blueprints and knowledge of how the machine is built. In the past, they share this information with a young scientist who becomes inspired, researches tirelessly, and eventually constructs the first working time machine. This machine then allows the original traveller to return to the past, beginning the cycle anew. So who invented time travel? The traveller, the young scientist, or the loop itself? In the language of calm nighttime reflection, we can simply say, the invention exists because the loop supports its existence. The story does not fracture under this arrangement. Instead, it settles into a pattern where origins are woven into outcomes, and outcomes into origins. The loop does not contradict itself. It completes itself. This concept may seem far removed from daily life, but its softness appears in more ordinary ways. Ideas sometimes feel as though they arrive without a clear source. You wake up with a melody in your mind, unsure whether you composed it or heard it somewhere long ago. A thought rises like a leaf drifting on a warm breeze. In these moments, the boundary between internal and external creation and memory becomes hazy. A bootstrap paradox is that feeling magnified across the fabric of time. One of the soothing qualities of these paradoxes is that they offer a different way of thinking about the universe. Instead of imagining time as a strict chain of dominoes, one falling after another, they open a view of time as a tapestry where threads can loop back and support earlier parts of the pattern. Events do not always need beginnings, they may simply need coherence. This aligns beautifully with the self-consistency we explored earlier. A bootstrap paradox is not a contradiction. It is a loop where each moment supports the next, and the next supports the previous, until the entire structure stands on its own. The universe in this picture is not confused by loops. It may even welcome them, as long as they maintain harmony. There is also a gentle philosophical comfort in the bootstrap idea. It suggests that not everything needs a single origin. Some things, ideas, memories, events, might be self-sustaining. They might arise because the universe allows patterns that do not depend on beginnings in the way we expect. Our craving for origin stories may simply be a human preference, not a cosmic requirement. This brings us to a quiet, perhaps surprising thought. If time loops can sustain objects, actions, or knowledge without a first cause, could time travel itself be such a phenomenon? Could it be a self-made event arising from a loop that has always existed, waiting for someone to step into it? If so, then the first time machine might never need a first inventor. It could be part of a closed cycle that shapes its own existence. This does not mean time travel is real. It simply means that the universe, through its equations, its curves, and the strange kindness of its consistency, does not forbid the idea. Instead, it leaves the door slightly open, allowing us to imagine loops that live peacefully within its logic. And so we drift toward a deeper question. If a loop in time can create itself, what role does the observer play? Does stepping into such a loop change its rhythm? Or does the loop, in some quiet way, shape the observer who walks through it? There is a gentle moment in physics, a quiet turning point, where the act of observing something transforms from being a simple act of noticing into something more participatory. It is the moment when looking becomes doing, when awareness becomes part of the event itself. In everyday life, we rarely feel this. When you glance at a candle, the candle does not flicker differently because you watched it. When you look at a leaf falling, the leaf does not change its path in response. But in the tiny quantum world, where everything is delicate and responsive, observation does more than reveal what is happening. It helps decide what can happen at all. This shift from noticing to participating is subtle, like touching a still pond with the tip of your finger. The pond was calm before, but your presence changes the ripples. You did not intend to alter the shape of the water, yet the act of observing brought your hand close enough to make a wave. Quantum observation is like this. To measure a particle's position or momentum, you must interact with it in some way. Shine light on it, nudge it with another particle, introduce a small signal that echoes back to your instruments. Each of these interactions leaves a trace. The universe feels the touch, even when the touch is soft. The result is that information is created. Before you measure the particle, it exists in many possible states, a hazy cloud of potential outcomes. After you measure it, only one outcome remains. The act of observing collapses this cloud into a single story, and in doing so, it adds something to the universe: clarity. A page has been written, a detail has been fixed. The world becomes more definite than it was a moment before. A comforting metaphor for this is a book without page numbers. Imagine reading such a book. You turn a page and you understand the words, but you do not know whether this is page 17 or page 70. The story exists, but its structure is vague. Now imagine gently writing a page number at the top. You have not changed the words on the page, but you have given the story a clearer shape. You have made the book easier to navigate. Observation in physics feels a little like this, placing a bookmark or a number on a page that was once unmarked. In the quantum world, these bookmarks can have far-reaching consequences. Before the observation, many versions of a particle's history are possible. After the observation, only one becomes meaningful. It is not that the other possibilities vanish dramatically, like mist being blown away. It is more like choosing a path in a quiet forest. Once you step onto one trail, the others remain, but only the one you walk becomes your story. This raises a soft but startling question. If observing can create information in the quantum world, Could observing time itself create, stabilize, or guide the way time unfolds? Time, after all, is not as fixed as it feels. Physicists have discovered that clocks tick differently depending on how fast they move or how close they are to a massive object. A clock in a speeding satellite ages more slowly than one on a quiet table. A clock placed on a high shelf ticks slightly faster than one on the floor. These differences are tiny, but they are real, and they tell us something gentle yet profound. Time is flexible. Time bends. It stretches. It adapts to the curves and motions of the universe. So, what happens when we observe time? When we measure its passage? When we try to pin down the exact moment something occurred? In a way, we do to time what we do to particles. We place bookmarks. We create structure. Without observers, time might remain a soft landscape of change with no clear boundaries. With observers, time becomes a sequence, a before and an after, a cause and an effect. This brings us closer to the idea that observation can become causation. Not causation in the forceful sense, like pushing a door open, but causation in a gentler way, like choosing which path the story will follow. In the quantum world, the result of a measurement determines which version of the past and future makes sense. The universe settles into a consistent narrative, and the act of measuring helps write that narrative. To illustrate this softly, imagine a garden maze. From above, you can see many possible routes: left turns, right turns, forks that lead back to the entrance or deeper into the hedge. But when you enter the maze and take your first step, your path begins to narrow. Every choice removes some possibilities and preserves others. You're not creating the maze, but you are creating the route you will take through it. Observation works in a similar way. It stabilizes one path through the maze of possible histories. This becomes even more intriguing when applied to time loops. If time can bend into a circle, then observing a moment within that circle might help anchor the sequence of events. A loop may contain many potential arrangements, but only those that are consistent. Those that fit the observer's choices and information can remain. Observation becomes the quiet mechanism that keeps the loop stable, ensuring that events within it do not contradict one another. In this sense, observing time is not passive. It becomes participatory. You do not force time to flow in a particular direction, but by paying attention, by measuring, by noticing, you help define the shape of the loop. You help select which version of events is allowed to exist. You place bookmarks in a book that is still being written. This notion echoes softly through some interpretations of quantum mechanics, which suggest that reality is not a fixed external object, but a network of relationships. When you observe something, you become part of that relationship. You add your awareness to the pattern, and the pattern shifts just slightly to include you. If this is true on the smallest scales, it may also be true in the broader realm of time. Perhaps the loops that might exist in the universe, those closed curves of cause and effect, need observers to take shape. Perhaps the act of witnessing a moment is what helps determine its place in the loop. Perhaps observation becomes a subtle kind of causation, not by imposing force but by stabilizing structure. The idea is gentle, not grand. It does not claim that thoughts reshape time. It simply suggests that observing time may be part of how time finds its shape. And as we drift deeper into the mystery, another question begins to glow softly at the edges. If attention can help shape what becomes real, what role does consciousness play in this unfolding story? Is it a force, a participant, or a lens through which reality reveals itself? We will wander toward that question next, following the quiet trail where observation and awareness meet the fabric of time. There is a gentle space between noticing and shaping, a place where consciousness feels less like a spotlight shining onto an external world and more like a lens through which the world takes on meaning. When we talk about consciousness in this soft way, we're not referring to something mystical or forceful. Instead, we're speaking about the quiet fact that awareness itself influences how reality appears, not by bending the universe with willpower, but by forming the bridge between possibility and experience. In everyday life, this is something we feel without needing to explain. When you walk through a garden, the flowers along the path become part of your moment, while the thousands of blossoms you never turn toward remain unseen. When you sit in a room full of soft murmurs, your mind selects one voice or one memory, allowing that chosen thread to become vivid while others drift away. Consciousness narrows the vastness of the world into a single experience, and in doing so, it shapes the story you live. This gentle filtering is not exclusive to the human mind. In a quiet sense, every act of observation, every measurement, every comparison, every interaction is a kind of lens. When a compass needle aligns itself with the Earth's magnetic field, it is observing that field. When a plant bends towards sunlight, it is noticing the direction of warmth. These are not conscious choices, but they are still interactions that define the shape of the system they belong to. Consciousness arises from the same kind of interactions, woven together on a more intricate scale. Physics has a way of expressing this idea that can be softened into an image. Reality is not an isolated object floating out there, but a relationship between the world and whatever observes it. If you imagine reality as music, then consciousness is not the composer. It is the listener who brings the melody to life. Without listening, the notes still exist, but they do not form a song. It is the presence of awareness that turns vibration into meaning. This perspective echoes gently through relational quantum mechanics, a way of interpreting the subatomic world that asks us to think differently about what is real. Instead of treating reality as a single, absolute structure that stands independently of all observers, relational quantum mechanics suggests that events are real relative to the systems that witness them. A particle does not carry a single, universal truth about its position or motion. It carries many truths, each defined by its interactions with something else. Reality, in this view, is a network of relationships, constantly shifting as new observations form new connections. To bring this into a peaceful nighttime image, imagine a lake at dawn. Two people stand on opposite shores. One sees ripples near the reeds, the other sees reflections of clouds. The lake is the same lake, yet each person's experience of it is shaped by where they stand and what they look toward. Relational reality works the same way. The world is shared, but the details each participant perceives arise from their unique relationship to the whole. This becomes even more intriguing when we bring time into the picture. If reality depends on relationships, and consciousness is one of the ways relationships are created, then attention itself becomes part of the unfolding order of events. We do not merely watch time pass, we give shape to its passage by noticing change. Without noticing, time becomes difficult to feel. Think of moments when you were deeply absorbed in something you enjoyed. Hours slipped by unnoticed, but when you waited anxiously for news, every minute stretched endlessly. Time responds softly to attention. Now imagine extending this idea beyond personal experience into the deeper structure of physics. If observing a particle helps resolve which path it takes, and if observing time helps clarify its rhythm, then consciousness, gently, quietly, may participate in shaping what becomes real. Not because the mind has supernatural abilities, but because awareness is part of the relational structure through which the universe expresses itself. This brings us toward a profound but peaceful question. If attention shapes what becomes real for us, could attention also shape what becomes possible? Think of how curiosity has guided human history. The moment we wondered how birds fly, we began to design wings. The moment we wondered what lay beyond the horizon, ships set sail. The moment we wondered about the nature of light, we built instruments to reveal its secrets. Each question opened a new branch of possibility, transforming the world gradually, sometimes invisibly, yet always meaningfully. In this sense, attention is not passive, it is generative. It brings potential into focus, encourages certain paths to be explored while others remain untouched. You could think of it as placing a small lantern at a fork in the road. The path you illuminate becomes easier to follow. The others fade gently into darkness. Now consider how this applies to time. When physicists began to measure time with greater accuracy, they discovered new layers of its behaviour. How it bends near massive bodies, how it slows with motion, how it emerges from quantum relationships. Each observation added clarity to the picture of what time can be, and with that clarity came new possibilities. Satellites that depend on precise timekeeping, technologies that account for subtle shifts in the flow of moments. Our attention to time reshaped our relationship to it. This raises a soft, speculative thought. If attention can shift what we know about time, and knowledge can shift what we do with time, then perhaps attention influences the future in ways we do not yet understand. Not by forcing events, but by guiding the possibilities we explore and the stories we choose to write. From here, the steps toward time travel, at least conceptually, become less abrupt. Instead of imagining time travel as a machine that tears open the universe, we begin to imagine it as a possibility that slowly comes into view, like a mountain emerging through morning fog. Our attention, our questions, our curiosity, they may be part of the process that reveals what time is capable of. In this gentle framing, consciousness becomes the quiet collaborator of reality. It does not command the universe, it harmonizes with it. And if attention can help bring new possibilities into focus, then perhaps time travel too might one day be one of those possibilities. But before we leap ahead, let us first listen for the faintest hint of how the future might whisper back to the present, shaping the very history that leads to itself. For in a universe woven from relationships, even the future may participate in the patterns of now. There is a quiet moment, rare and almost fragile, when we let ourselves imagine the future not as a distant horizon, but as a presence that leans gently toward us. Most of the time, the future feels far away, like a soft glow beyond the edge of the hills. But every so often, in the stillness of late night or the calm between two thoughts, the future seems to draw just close enough that we can sense it, not as a force, not as something that acts upon us, but as a whisper, a possibility brushing lightly against the present. Tonight, we drift into one of the most intriguing ideas in the study of time, that futures which could exist may subtly guide the paths that lead to them, not through intervention or manipulation, but through a quiet, natural alignment, like water in a valley finding the path that best allows it to flow. To approach this idea gently, imagine a world centuries from now, where humans have learned to shape space-time with precision, perhaps bending its fabric the way we now bend light through lenses or electricity through circuits. In this imagined future, time travel, at least in some form, has become real. Not dramatic jumps across centuries with flashing lights and shimmering portals, but perhaps loops, shortcuts, or paths that allow travellers to step into a moment that existed before their own. But how did this future come to be? What chain of events gave rise to it? What sequence, spanning research, curiosity, accidents, insights, and leaps of imagination, led humanity toward the ability to fold time? Now consider this. If the future includes time travel, then the timeline we inhabit today may already be one of the histories that naturally leads there. Not because the future reached back and altered the present, but because the future and the present exist in a relationship, each one selecting the other in a soft, self-consistent loop. We can think of it through a gentle metaphor. Imagine water flowing down a mountainside. It may split into several streams wandering through stones and soil. But if there is a deep valley waiting below, the streams will eventually converge there, not because the valley pulls them with force, but because the shape of the land naturally guides the water toward that lowest point. The future in this metaphor is like the valley. The present is like the flowing water. The two meet not by miracle, but by the simple coherence of the landscape. In quantum physics, there is a concept called post-selection, which we can soften into an image instead of using sharp terms. Imagine choosing a destination at the end of a journey, and then walking the paths that eventually lead you there. The endpoint does not push you, but it shapes your choices. The landscape of possibilities adjusts quietly so that the final destination makes sense. In this soft interpretation, the future selects the past by making certain paths harmonious and others less likely. Applying this to time travel is not a scientific claim. It is a philosophical meditation inspired by how quantum systems behave. If a future where time travel exists is part of the tapestry of the universe, then the present might naturally drift toward that future. Not because the future reaches back in time, but because the entire timeline forms a shape that supports itself. Another way to picture this is to imagine a piece of music played backward and forward at the same time. The notes must still harmonize. The melody cannot contradict itself. If the final note is clear and resonant, then the notes leading up to it must arrange themselves into a pattern that fits. They do not force one another, they coexist in a way that forms complete song. In this quiet analogy, the present and the future are part of the same melody, each one helping to define the other. This idea becomes even more intriguing when we think about human curiosity. Suppose someone in the future, with access to time loops or shortcuts, becomes fascinated by how the first sparks of temporal research began. They observe the timeline, tracing the threads backward, searching for where it all started. Their observation does not change our present in any direct way. But by focusing on certain threads, ideas, people, experiments, they illuminate those parts of history more brightly. Like shining a lantern down a corridor, their attention makes certain paths more meaningful, and the present, in decades or centuries earlier, naturally moves along those illuminated paths simply because they are clearer, easier to follow, more resonant. The future does not impose itself. It merely listens, and in listening highlights the routes that will eventually lead to itself. A gentle analogy for this is the sound of an echo in a canyon. When you speak, the canyon walls send your voice back to you. You do not change the canyon with your voice, yet your echo influences how you hear the space, shaping your next words. In a similar way, the future might echo faintly into the present, not through force, but through resonance. The shape of what may come gently influences the shape of what we choose to see. This brings us to a soft version of the idea. Perhaps the future does not change the past, but the future and the past coexist in a pattern where each supports the other. A timeline containing time travel must shape itself into a loop that makes sense. The future that wishes to exist will align with the past that supports it. And our present in this picture is simply one of the points where this alignment becomes visible. There is something soothing in this view. It suggests that the universe may be less like a sequence of disconnected events, and more like a whole piece of fabric, woven from all directions at once, past and future meeting in the middle. And if time travel is ever to exist, then our curiosity about it today, our stories and questions, our philosophical wanderings, may be part of the very pattern that makes it possible. Not because we summon it by wishing, but because the desire to understand time is part of the valley through which the future's river flows. In this gentle framing, the future is not a distant, unreachable realm. It is a partner in a cosmic conversation. And the faint whisper we sometimes feel, when we sense a possibility that has not yet come to pass, might be the soft resonance of a timeline that is already complete, already harmonious, already waiting for us to grow into it. But before we reach too far, we pause here. For if the future plays a role in selecting the path of the present, then our desires, our dreams, and our quiet obsessions might also play a part in shaping what time becomes. And that is where our journey will drift next. There is a gentle truth woven into human history. Almost everything extraordinary we have ever achieved began as a quiet desire. Before there were ships, someone wondered what lay beyond the horizon. Before there were telescopes, someone looked up at the night sky and wished to see further. Before there were engines, someone imagined moving faster than the wind. Desire is often the first ripple in the still water, the soft stirring that precedes discovery. It is not forceful or dramatic. It is simply a direction in the mind, a leaning forward into possibility. When we think about time travel, that same longing has been with us for centuries, long before theories of space-time, long before quantum experiments, long before the idea of curved universes or loops in time. People told stories of stepping into the past or glimpsing the future. They wrote poems about lost opportunities and imagined rewriting history. They dreamed of returning to moments that had slipped away like sand through their fingers. These desires were not scientific hypotheses. They were emotional truths, the wish to understand time, to make peace with it, or to wander through its corridors. And in a very soft way, desire can be a kind of observation. When you wish for something, you pay attention to it. You notice it in the world. You imagine it more clearly. You turn your thoughts toward it, again and again, and with each return the idea becomes more vivid, more structured, more real. Not physically real, but imaginally real, like a constellation forming out of scattered stars. In this gentle sense, desire is a lantern that illuminates a path through the landscape of possibility. Humanity's long fascination with time travel has done more than entertain us. It has shaped the questions scientists ask. It has influenced the theories they explore. It has guided the experiments they design. The desire for time travel is not a scientific force, but it is an intellectual one. It guides attention, and attention guides inquiry, and inquiry shapes the boundaries of what becomes possible. If we think of attention as a kind of soft nudge, one that encourages the universe to reveal certain patterns more readily, then desire is the very first push. It is the seed from which curiosity grows. It is the spark that lights the lantern long before anyone knows how to walk the path it reveals. Imagine a child sitting beside a window at night staring at the stars. They know nothing yet of gravity, or relativity, or quantum fields. They only know wonder. And that wonder, that wide-eyed longing to understand the sky, is the first step on a journey that might eventually lead them to become a scientist who asks new questions about time. Their life becomes a thread woven into the fabric of discovery, all because of a small desire felt in childhood. This is how the universe often works, quietly, through the smallest of beginnings. In this way, desire is not trivial, it is formative. Every invention begins as a quiet wish. Every theory begins as a question that refuses to leave the mind. Every breakthrough begins as a curiosity that lingers, like a soft echo in the background of consciousness. Without desire, we would never push our understanding forward. Without desire, we would not notice the unusual patterns that lead us to new knowledge. Without desire, we might never look closely enough at time to see its hidden structure. Now imagine for a moment a future in which time travel exists, whether through loops, shortcuts, or other ways of bending the fabric of time. Imagine that future looking back toward us, noticing the early stages of the path that will eventually lead to its own creation. In that future, scientists examine old theories, quaint experiments, and early attempts to understand the nature of time. They see our present curiosity as the first shimmering thread of a tapestry they now inhabit. In this imagined future, our present-day desire for time travel becomes meaningful. It becomes part of the story. It might even become part of the loop. A future with time travel would require a past that supported its development. And that past may begin with something as gentle as longing. humanity's shared emotional response to time's flow. This does not imply that desire alone creates time travel. The universe does not bend itself to our wishes, but desire directs attention, and attention guides discovery. Readers become thinkers. Thinkers become scientists. Scientists become explorers of time. Each step is small, but together they form a path. And if the future contains time travel, then this path must exist in the present. In a self-consistent universe, every part of the loop supports every other part. To soften this further, picture a seed falling into soil. The seed does not know the shape of the tree it will become. It does not know the landscape it will eventually inhabit. Yet the tree exists potentially within the seed, and the seed exists meaningfully within the tree's history. The future tree depends on the seed, even though the seed cannot see that future. Desire is like that seed. It holds no technology, no theories, no equations. It simply holds potential. The quiet potential that someday, perhaps through generations of thought and exploration, something extraordinary may grow. This gentle interplay between desire and possibility mirrors how discoveries often unfold. A new idea begins in imagination before it exists in the world. A possibility takes shape in thought before it solidifies in practice. A dream becomes a question becomes a study becomes a discovery. When viewed from a distant future, the line between dream and invention becomes thin. They are two parts of the same arc. So when we consider the question of whether observation might help create the loops in time that allow time travel, we must also consider the first form of observation, desire, the wish to understand time, the longing to revisit moments, the curiosity about what lies ahead. Perhaps these desires are not merely fantasies. Perhaps they are the earliest stage in a long looping process, the first whisper of a possibility that the universe may already know how to embrace. And as we drift toward the next part of our journey, another gentle thought arises. If desire is the beginning of the loop, could inspiration, intuition, or sudden insight be the soft echo returning from the future? Could the ideas that arrive in us be seeds planted by what we have yet to become? There is a feeling, quiet, almost impossible to pin down, that sometimes arrives in a moment of stillness. You may be walking alone in the late afternoon when the light softens and shadows grow longer, and suddenly a thought appears in your mind with no clear origin. It doesn't come from memory, and it doesn't feel quite like imagination either. It feels like something placed gently in your hands, an idea, a direction, a small, delicate pull towards something you cannot yet name. We often call these moments intuition, inspiration, or sudden clarity. They feel like sparks that rise without warning, lighting up a corner of our consciousness. But tonight we will follow a softer question. Where do such sparks come from? Are they simply the scattered wanderings of the mind? Or could they be part of a deeper pattern, a quiet resonance between what we are now and what we may one day become? To explore this peacefully, imagine a future where humanity has learned to move through time in subtle ways, not leaping centuries in a flash of light, but using gentle curves and folds in the fabric of space-time, loops that allow travellers to step into moments long past or long ahead. In that future, time is not a wall to be stared at from one side. It is a landscape to be walked, a terrain with valleys, ridges, and hidden paths. Now imagine a scientist in that distant era, living in a world where time loops are understood, studied, and woven into daily life. They may be curious about the origins of the field, how humanity first began to sense the flexibility of time, how the earliest hints of temporal structure were discovered, how the first theories emerged. They look back, not by travelling, not by interfering, but simply by observing the long thread of history. Their attention lands on certain figures, People who asked unusual questions, who sensed something soft and mysterious about time, who followed curiosity where it led. Their gaze, even from centuries ahead, highlights these threads. And suddenly, from our perspective in the present, these ideas seem to emerge more brightly. Paths that lead toward understanding feel clearer. Curiosity deepens. Intuition strengthens. Not because the future is pushing us, but because the entire timeline, past, present, and future, is woven into a single pattern where each part supports the rest. This is not intervention. It is resonance. A gentle metaphor for this is a wind stirring through a field of tall grass. The wind does not choose a single blade to bend. It simply moves, and the blades that are already leaning slightly in one direction sway more easily. Those blades become visible, noticeable, meaningful. In the same way, the future does not send us messages. But when we are already leaning towards certain ideas, time, memory, loops, possibility, those ideas may sway more readily, as though they were waiting for a breeze that arrives from beyond the horizon. These whispers of the future can sometimes feel like intuition. Inspiration may arrive like a seed drifting on a current of air. You do not know where it came from, yet it lands perfectly in the soil of your mind. In the quiet moments when these ideas appear, you might think of them as gifts from your future self, soft echoes travelling backward across the landscape of time, not changing the past but illuminating the paths that will guide your steps. Imagine a researcher deep in thought. For days they puzzle over an equation, a theory, a pattern in nature. Then suddenly, at dawn or in the middle of the night, insight blooms. They see the problem differently. They understand. History is full of such moments, sudden leaps, flashes of clarity that transform the course of science. These breakthroughs feel almost out of nowhere, yet they are part of a long story of thought, preparations made unconsciously, fragments of knowledge aligning, future implications shimmering faintly behind present understanding. Perhaps, in a poetic sense, these moments can be seen as seeds planted by futures that need them, not through force, not through deliberate design, but through the natural coherence of a timeline where certain discoveries must emerge for later events to make sense. If a future depends on the existence of time travel, then the present must contain the early ideas that allow it to develop, and if attention shapes possibility, then the future's attention to its own origins may gently illuminate those origins in the present. Another soft way to picture this is to imagine a piece of music played across a long corridor. You're at one end, hearing the faintest hints of notes drifting through the air. The musician is far away, perhaps in another room entirely. They are not playing for you specifically, they are simply playing. But the melody reaches you anyway, guiding your footsteps, shaping the emotions you carry, suggesting directions you might walk. The future, in this analogy, is the distant musician. We hear only faint tones, but sometimes those tones are enough to guide us. Of course, none of this suggests that the future controls the present, or that ideas are literally transmitted backward in time. The universe does not appear to work that way. What we're exploring instead is the idea that the timeline may be shaped as a whole in a way that feels harmonious. A future that needs certain discoveries may naturally coexist with a past where those discoveries arise. The timeline supports itself, like a tree growing from roots it cannot see, but that somehow always lead to its branches. This view also softens the sharp edges of time travel. Instead of imagining paradoxes and disruptions, we imagine harmony. Instead of imagining interference, we imagine alignment. The future does not rewrite the past. It simply coexists with it in a way that feels like a dance, quiet steps that match, even across centuries, and the present becomes the meeting ground where that dance takes shape. In this soft framework, inspiration becomes more than a mental event. It becomes part of the relationship between what we are and what we may become. Intuition becomes a whisper of coherence. Insight becomes a thread woven between now and later. And so we drift toward a peaceful question. If the future can resonate with the present through attention, curiosity, and coherence, then what happens when we ask questions about time itself? When we study it closely? When we wonder about it deeply? When we open ourselves to possibilities? What might the universe reveal in response? What paths might light up beneath our feet that we could not see before? There is a gentle wonder that unfolds when we realize just how much of human progress began with a simple question. Before there were answers, before there were theories or instruments or experiments, there was curiosity, soft, persistent, and quietly brave. A question is not forceful. It does not bend the world by sheer will, but it has a way of opening a small door in the mind, allowing light to pour through in unexpected ways. And sometimes, that light reveals possibilities that had always been there, waiting patiently to be noticed. Think of how our understanding of light itself changed through questioning. For centuries, people wondered what light was. Was it a stream of particles? Was it a wave? Was it something else entirely? By simply asking this, by turning attention toward it, humanity discovered prisms, lenses, lasers, fiber optic cables, and even the technology that allows you to watch this video. Light did not change because we asked about it, but our relationship with light changed. We learned to guide it, shape it, bend it, sometimes gently, sometimes powerfully, because we paid attention to it. The same is true for gravity. Before we asked what kept our feet on the earth, gravity was simply the quiet force that held us. When we turned curiosity toward it, we found orbits, trajectories, and the curvature of space-time. We discovered that time itself slows in the presence of strong gravity, stretching in ways we cannot feel but can measure. The universe did not suddenly begin to behave differently. We simply noticed what had always been true, and that noticing opened doors to satellites, spaceflight, and technologies that depend on precise timing. Now imagine applying this same gentle process to time itself. When we ask what time is, when we wonder about its structure, its flexibility, its hidden patterns, we begin to see things we never noticed before. We find that time is not uniform. It can stretch and shrink. It can twist in the presence of motion and mass. It can appear or disappear depending on how systems relate to one another at the quantum level. None of this happens because we will it to happen. It happens because the universe responds to our questions by revealing patterns we did not know how to look for. In this sense, questions are creative forces, not because they generate reality from nothing, but because they generate ways of understanding reality that were previously invisible. When you ask a question, you change your perspective. You place your attention on a particular corner of the world, and in doing so, you see details that were once lost in the background. The universe does not rearrange itself in response to curiosity. Rather, curiosity rearranges the lens through which we see the universe. This is how so many discoveries begin. A scientist asks a question that seems simple. Why does this behave differently than that? What is hidden inside this pattern? Is there something we have overlooked? These questions become experiments. Experiments become data. Data becomes insight. And insight becomes technology, knowledge, or wisdom that reshapes the world. Now imagine that time travel, in whatever form it may one day exist, is hidden somewhere in the vast landscape of possibilities. Not as a dramatic tear through reality, but as a subtle feature of the universe, like gravity's ability to bend time or like light's ability to act both as a wave and a particle. If time travel exists in potential, then questions may be the first step toward discovering how to approach it. When we wonder whether time can loop, we discover closed time-like curves in the mathematics of space-time. When we wonder how particles behave, we find delayed choice experiments where the present seems to influence what counts as the past. When we wonder how information shapes reality, We find that quantum systems respond to measurement by selecting one history out of many. Each of these discoveries began as a question. Each one turned our attention toward the structure of time. This is not magic. It is not wishful thinking. It is the natural rhythm of curiosity guiding us toward understanding. When you ask a question deeply enough, you begin to see the world with new eyes. And when humanity asks questions collectively, across generations, across cultures, across disciplines, the effect is profound. The questions accumulate, forming a scaffolding of wonder from which new ideas can emerge. Think of a quiet field where seeds have been scattered. Each seed is a question. Some lie dormant for years, some sprout quickly, some grow into towering trees. When the wind moves through the field, the trees sway, and their shadows touch the seeds below, warming them. In time, more seeds take root. Questions nourish other questions. Curiosity grows into a forest. Now consider a future where time travel exists, not because someone forced the universe to yield its secrets, but because generations of people kept asking, what is time? Why does it behave this way? What are the boundaries of possibility? If time travel is ever discovered, it might not feel like a sudden leap, but rather the natural flowering of questions that were planted centuries before. In this gentle framework, the universe does respond to our questions, not by bending itself to our desires, but by revealing pathways that are already there, waiting to be seen. A question is like a hand brushing across a wall in the dark. You do not create a door by touching the wall, but you may discover a doorway that was always hidden just out of sight. This invites a soft reflection. Perhaps the universe contains many doorways, many paths, many loops in time that are not obvious from our everyday experience. And perhaps the act of questioning, curiosity itself, is what guides us toward the ones we're ready to see. If that is true, then time travel may not begin with machinery or equations. It may begin with something quieter, our desire to understand time, our attention to its mysteries, and the simple, profound act of asking, could this be possible? In a universe where observation shapes experience and curiosity illuminates potential, questions become part of the gentle machinery that reveals what time can be. As we drift forward, the next thought rises softly. If time travel is something the universe allows, then perhaps our deepest questions are already helping shape the path toward it. And if we are indeed participants in a cosmic dialogue, then what we ask, carefully, quietly, may matter more than we imagine. There is a moment, soft, steady, almost like the hush before dawn, when you begin to realize that the story of time is not just a story about clocks or physics or distant futures. It is also, quietly, a story about us, about the role we play in noticing, wondering, imagining, and shaping the world we move through. And if time travel is something that could ever create itself, emerging through loops, resonances, observations, and the long arc of curiosity, then we must ask a gentle, almost whispered question. What does that make us within this unfolding universe? To explore this, let us return to the idea that observation does more than reveal the world. It participates in it. When we observe the world around us, we help shape what becomes meaningful, what becomes real within our experience. And when we observe time itself, its rhythms, its mysteries, its hidden structures, we may play a quiet role in how time expresses those possibilities. If the universe is a canvas, then perhaps we're not merely viewers standing in front of the artwork. Perhaps we are also part of the brush strokes, woven into the painting, influencing its textures simply by being present inside it. The universe does not bend to our will, but it may respond to our attention, the way a string vibrates when another string nearby is plucked, not by force, but by resonance. And if this is true, then time travel, if it ever exists, would not arise from a place outside of us. It would arise through us, through our curiosity, our observations, our longing to understand what time truly is. In this sense, we become participants in a cosmic feedback loop, where the future and the past quietly support one another, and where the present is the soft meeting point between them. This idea becomes clearer if we imagine the timeline not as a rigid line, but as a living landscape. Imagine a valley carved by water flowing through it over ages. The water shapes the valley, and the valley shapes the water's path. Neither one dominates. They form each other in a long, slow conversation. In the same way, the future may shape the kinds of questions we ask today, and our questions may shape the kind of future that can exist. Time becomes a dialogue, not a one-way street. If time travel creates itself, it may do so through moments like this one, moments of quiet reflection, where we consider what time is and how deeply we are connected to it. Our questions, our hopes, our dreams, the stories we tell, the science we explore, they become threads in a tapestry that the future may later rely on. In this view, we are not passive inhabitants of the universe. We are part of its self-unfolding. This leads to a gentle ethical question. What should we do with a universe that listens? If our attention helps shape what becomes possible, then the quality of our attention matters. Curiosity becomes a meaningful force. Wonder becomes a kind of responsibility. Awe becomes a way of participating in the universe with humility. Imagine holding a lantern in a dark forest. The lantern does not command the trees to grow or the ground to form, but the light helps you see the path, and the path you choose becomes part of your experience, and perhaps part of the shared story of those who will walk after you. In the same way, our questions illuminate possible futures. The light we carry shapes the paths we are able to see. Now think of a future where time travel has long existed. Perhaps travelers step gently into loops of time, not to rewrite history, but to understand it more deeply. They do not disturb the timeline because they cannot. Time loops allow only harmonious actions. Instead, traveling becomes a form of listening, a way to witness the universe from different angles, to appreciate the contours of time the way you might walk slowly around a sculpture, noticing shadows and curves. If we imagine such a future, then what we do now becomes part of the foundation that supports it. Our curiosity is the soil, our questions are the seeds, our stories are the water that nourishes them. If time travel does create itself, then we are contributing to that creation simply by being the kind of beings who wonder about it at all. This also brings us to a more personal reflection. What does it mean to be a participant in time? We often speak of time as something that carries us like a river, but perhaps we also shape the river's meaning through every choice we make, every memory we carry, every dream we hold. Time is not just outside of us, it is inside us. The rhythm of our heartbeat, the cycles of our thoughts, the arc of our life. And if we shape time in our minds, perhaps time shapes us in return. So what does that make us? It makes us co-creators of meaning. It makes us partners in the unfolding story of the universe. It makes us listeners who help the universe speak more clearly, simply by paying attention. It makes us lantern bearers walking through the twilight of possibilities, illuminating paths that might otherwise stay hidden. And if time travel is one of those paths, then perhaps we are already helping to reveal it. Not dramatically, but gently, through curiosity, wonder, and care. As this journey reaches its quiet end, we can picture the universe as a vast canvas stretching far beyond sight. Time moves across this canvas like a soft tide, shaping patterns that are too large for any one moment to understand. And each of us carries a small lantern, lighting the space around us, participating in that cosmic artwork simply by being present, by noticing, by hoping, by asking. And now, as the final notes of this reflection settle, we drift into the soft closing of our journey. Hello there, and thank you for wandering through this gentle meditation on time with me. Whether your eyes are still open or drifting into dreams, I hope this exploration has brought you a sense of calm wonder. In this quiet corner of the cosmos, your presence truly matters. If you'd like to join me again for more soft journeys through science and imagination, you're always welcome to return. Until then, may time move gently around you like a tide that carries you toward rest. Sleep peacefully wherever and whenever you are, and